Hello everyone. So today in this video we are going to solve a question of LeetCode, that is score of parenthesis. It is 856th question on LeetCode and it comes under medium category. Alright, so let's start with the problem statement. Given a balanced parenthesis string S, return the score of the string. So basically in this question we have given a string S and we need to calculate the score of this string according to few parameters given here. Alright, so let's quickly understand with an example. So let me make a multi-line comment here. Yeah, so these examples are straightforward. Let's take a custom example here. So let's take a custom test case. So we will be taking this test case as our example, and let's quickly see how can we do this. And let's take I is equal to 0 and let's make a stack. Initially it is empty. Alright, so whenever we get opening parenthesis, we will just push it into our stack, and we will push I into our stack. The approach which we're gonna follow is that we will be calculating I such that, like we have seen here, like opening and opening closing parenthesis has score 1. So when we calculate it manually, we see like we have a opening closing parenthesis here, so its score would be 1. Then we have opening and closing parenthesis outside it, as we have seen here, so it will be equal to 2 into and inside 1, that is 1, so it will be, the total is 2. Then we have again opening closing parenthesis, so the total answer is 3. This we have calculated manually. Let's see how can we do this through code. So whenever we get a closing parenthesis, we will calculate I according to it. So let's say I will be equal to st top. So stack dot top. Stack dot top is basically storing the I of recent pairs. So stack dot top plus maximum of 2 into I comma 1. This I will be the calculated I whenever we get a closing parenthesis. So let's quickly see and iterate through our given string. So for the 0th index we get a opening parenthesis. So whenever we get a opening parenthesis, we will just push I into our stack. So current I is 0. Let's push 0 into our stack. then we again get a opening parenthesis. So again we push I into our stack. Now we have a closing parenthesis. So whenever we get a closing parenthesis, we will calculate through this example, like this formula. So I will be equal to stack dot top. So stack dot top is currently 0 and maximum of 2 into I comma 1. So 2 into I is 0 and 1. So maximum is 1. So I will be updated to 1 and we will just pop out from the stack. Now we are at this position. So again we have a closing parenthesis. So for the closing parenthesis, let's calculate I. So stack dot top is 0. Let's pop it out plus maximum of 2 into I. So I is 1. So 2 into I is 2. So maximum out of these is 2. So let's update I to 2. Now we have a opening parenthesis here. So whenever we get opening parenthesis, let's push it into our stack. So we will push I, a current I is 2. Now we will just change I to 0 as we have pushed into our stack. Like after pushing into a stack, we will just change I to 0. Now we have a closing parenthesis. Whenever we get a closing parenthesis, we calculate it using this formula. So stack dot top is 2 plus maximum of 2 into I comma 1. So 2 into I is 0 and 1. So maximum out of this is 1. So stack dot top plus 1, that is 2 plus 1 is equal to 3. So I will be updated to 3 and let's pop it out from here. Now we have iterated through our string and at the end the I is equal to 3. So we will just return I from here. So in this case I is 3. So our answer is 3 as we have calculated manually, and after calculating it through this formula we also get 3 as our answer. So I hope the approach is clear to you. Let's quickly code the solution. So let's initialize a stack of integer here and let's run a for loop. which will be iterating to all the characters of the string, and if we get x is equal to opening parenthesis, we will just push it into our stack, and let's initialize a variable int I is equal to 0, and let's initialize 0. Whenever we push into our stack, we will just update I to 0. Then if x is equal to the closing parenthesis, what we will do, we will just update I with our formula which we have seen earlier. So I will be equal to st.top plus maximum of I into 2 comma 1, and let's pop it out from the stack. Alright, at the end just return I from here. I hope it should work fine. Let's just run it. It's not working fine. Let me check. We might have done some mistake here. Okay, so we were pushing x, it should be I here. Yeah, so let's run it. Yeah, it's working fine. Let's just submit it. Because we are pushing the x, we are not pushing the x, we are just pushing the current value of I into our stack. That's why we should update I here. Alright, so that's it for this approach. Let's calculate the time and space complexity. So time complexity of this approach is big O of n, and space complexity of this approach is big O of n, because we are storing all the n elements into our stack. So this approach is not much efficient because we are using n characters as a space here. So to optimize this, we can use two variables which will be storing the number of closing and opening and closing parentheses, and will keep a track of all these parentheses. So let's see the second approach and the most optimized approach which we can do in this question. So let's clear it out and let's code this optimized approach. So let's take two variables, int answer is equal to 0, and let's take one more. Let's name it balance for now. Balance equal to 0. Now let's run a for loop int I equal to 0. I should be less than s dot size and I plus plus. Alright, now let's check if si is equal to opening parenthesis, then we will just increment balance, else decrement balance. This is, we are just calculating the basic approach we are following here. Whenever we get a opening parenthesis, we will just increment, and whenever we get a closing parenthesis, we will just decrement the balance. Alright, now let's check if si is equal to closing parenthesis and as I minus 1, like the previous one, is equal to opening parenthesis. So we must be getting a pair. So in this condition, let's update answer plus equal to balance. Alright, so at the end just return answer from here. I hope it should work fine. Let's just run it. Yeah, it's working fine. Now let's just submit it. Yeah, it's perfectly fine. Now let's calculate the time and space complexity. So time complexity is same. Now the updated space complexity is big O of 1 because we are using constant spaces here. So that's it in this video. I hope you understood it, both the approaches. If you still have any doubt in this approach, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.